This is the nightmare of every developer, a database migration gone wrong. Unlike application code, which is stateless and easy to roll back, databases are heavy, persistent, and full of state. When you change the structure of your data, you're performing open-heart surgery on a living system while it's still running. In this video, we are going to explore why database migrations are considered one of the riskiest operations in software engineering. We'll look at the technical hurdles, the locking mechanisms that can bring traffic to a halt, and why the simple undo button doesn't really exist for your data. By the end, you'll understand why even the most senior engineers hold their breath when running a migration script. To understand the risk, we first need to distinguish between code and data. When you deploy a new version of your app, you're replacing stateless logic. If it fails, you just point your load balancer back to the old version. But data has gravity. A database migration isn't just a logic change, it's a physical reorganization of bits on a disk. If you rename a column, the database has to update its internal catalog, and in some cases, rewrite every single row in that table. This takes time and resources. While the database is busy moving these bits around, it might stop responding to your users. This fundamental difference, the fact that data persists and changes over time, is exactly why you can't just revert a migration as easily as you revert a Git commit. The biggest silent killer in migrations is the table lock. Most relational databases like Postgres or MySQL need to ensure consistency. When you perform an operation like adding a column with a default value or changing a data type, the engine often places an exclusive lock on that table. While that lock is held, no other process can read or write to that table. If your table has millions of rows, that migration might take minutes. During those minutes, every single request from your users piles up in a queue. Eventually, your connection pool exhausts and your entire application crashes. This is why a simple alter table command that worked perfectly on your small local machine can destroy a production environment with high traffic. Then there's the issue of data volume and time. On your development machine, a migration runs on 100 rows and takes 10 milliseconds. In production, you might have 100 million rows. Suddenly, that 10 millisecond task becomes a 2-hour ordeal. Long-running migrations are dangerous for several reasons. First, they create replication lag. Your primary database is busy doing the migration, but your read replicas are struggling to keep up with the massive stream of changes. This can lead to users seeing stale data or even errors if the replica doesn't have the new schema yet. Second, the longer a transaction stays open, the more likely it is to cause a deadlock with other background processes like auto vacuum or scheduled backups. You're effectively racing against the clock. Let's talk about the rollback paradox. When a code deployment fails, you revert to the previous container image. But if a database migration fails halfway through, you are often left in an inconsistent state. Imagine you are migrating data from an old users table to a new profiles table. You've moved 50% of the data, and then the migration crashes. You can't just undo, because some new users might have already signed up and their data is only in the new format. Attempting to roll back could actually cause more data loss than the failure itself. This is why we often say database migrations are one-way streets. Once you start moving data around, your primary focus shifts from rolling back to rolling forward, fixing the issue in place, because there's no safe way to go back in time. Finally, we have the dual write problem. During a migration, your application code and your database schema must be in sync. If you delete a column that the old version of your app is still trying to read, your app will crash. This requires a carefully orchestrated multi-step process. First, you add the new column. Then you update the code to write to both the old and new columns. Next, you migrate existing data. Then you update the code to read only from the new column. Finally, you delete the old column. Skipping any of these steps or getting the order wrong is a recipe for disaster. This complexity is why migrations take up so much engineering time. You're not just writing a script, you're coordinating a dance between different versions of your software across multiple servers. The answer lies in automation and testing. Use tools like Flyway or Liquibase to version your schema. Always test your migrations against a production-sized dataset in a staging environment. This helps you catch those nasty table locks before they hit real users. Implement expand and contract patterns to avoid downtime, and always have a monitoring dashboard ready to watch for spikes in database load or replication log. Database migrations will always be risky because they involve the most precious part of your business, the data. But with a disciplined approach, they don't have to be a nightmare. Thanks for watching, and may your migrations always return a success code.